My presentation is titled Noctis Landing, Mars, Finding an Optimal Landing Site for the Human Exploration of Mars. I was tasked with finding an optimal landing site within a region previously identified to be of great interest for the human exploration of Mars. My name is Krista Heinemann, and my mentor is Dr. Pascal Lee. So just as some background, this is a map of all the landers and rovers we have sent to Mars. The green dots are successes, the red dots are crashes/failures, and the yellow dots are partial successes. Historically, we have generally landed in relatively boring areas on Mars, places that were flat, smooth, and safe over large open areas. Scientifically, more interesting places like volcanoes, valleys, and canyons are considered riskier to get to. In 2015, NASA had a workshop asking for potential landing sites/exploration zones, which are 100-kilometer circles around landing sites, for human missions to the surface of Mars. My mentor, Pascal, and his team proposed what they named Noctis Landing, which I circled in black on this map. This region is very scientifically interesting for a variety of reasons. One being its proximity to several Martian volcanoes, some of which are circled in yellow on the map. If there is living life on Mars today, it would more likely be located in the caves of these volcanoes. Another reason this region was of interest is because it gives access to the Valles Marineris, circled in blue on the map. The Valles Marineris is a series of canyons on Mars. It provides exposure to ancient Mars rock layers, which makes it a great place to search for past life on Mars. So, zooming in to the Noctis landing area, the yellow box is the area that my project was focused on. The yellow dot is the approximate location of the Noctis landing site Pascal and his team proposed in 2015. Earlier this year, while exploring the area around their candidate landing site, Pascal and his team found the remains of a modern glacier. I marked the approximate location of this relic glacier in blue. This relic glacier is of great scientific interest because it suggests that Mars had water ice activity on the surface and maybe even life in recent times near the equator. Additionally, if water ice still exists there today, it would be a great resource for astronauts. You may also notice the area imaged in the gray rectangle. That is the Pink Panther Pit, a large depression in the landscape, which we will come back to later. Here is a zoomed-in photo of the relic glacier. We do not know for sure if there is water ice present today because when we take the chemical composition of this feature shown in light blue from orbiters, it comes up as salt, not water ice. But many of the details seen in this light blue formation are uniquely characteristic of glaciers. The parallel lines you see in the zoomed-in image are crevasses, a very distinct glacier feature. My mentor Pascal and his team hypothesized that there may still be water ice hidden underneath a layer of salt. The red-colored material is volcanic ash, blanketing part of the relic glacier. Pascal and his team had proposed the landing site marked in yellow before the relic glacier marked in blue was found. My task was to see if I could find a new, more optimal candidate landing site within the Noctis landing region that would be closer to the relic glacier. The imaging analysis and mapping tool I used to search for landing site candidates was Google Earth Pro, an application that I was able to just download off of Google. Within the app, I went to the Mars globe option. I was then able to view high-resolution images of Mars taken from Mars orbiters. The screenshot on the right shows what that looked like. looks like. Each of the yellow or red boxes is a high-resolution image taken from either one of two American orbiters around Mars, NASA's Mars Global Surveyor or NASA's Mars Reconnaissance Orbiter. As for the criteria for what would make a good landing site, for a human mission to Mars, I was looking for an approximately 1 square kilometer area that was smooth, meaning it had less than 5-degree slopes, and flat, meaning it was not too bouldery or covered in tall sand dunes. This would allow for safe landings and the eventual establishment of a base on Mars. I was also looking for a landing site that could give you good access to the surrounding region via a rover, meaning a smooth patch in the middle of a big sand dune field would not be a very good place to land, because if you can land but then not get anywhere, that would not be very helpful for exploring Mars. Furthermore, I was looking for a site that is close to scientific features of interest. We were successful in finding a new candidate landing site within the Noctis landing region for human missions to the surface of Mars. These are high-resolution images of our new candidate landing site. You may notice that it is not perfectly smooth. Those little ripples are small sand dunes. You are on Mars, so sand dunes are very difficult to avoid because they are everywhere. As a result, the key is to minimize them to the best of your ability. In addition to meeting our basic safety and logistical criteria, this particular site stood out to me and my mentor and I for scientific reasons as well. For one, the location is centralized between our 3 main points of interest, the Relic Glacier, as well as the Pink Panther and Dragon Pits. With the white box being our candidate landing site, the central location gives us relatively easy access to all 3 of these places. The Relic Glacier would be scientifically very interesting, and then if water ice turns out to still be there, it would be a great resource for astronauts. The Pink Panther and Dragon Pits are of interest to us because they expose older rock layers, which can then be studied to get a better understanding of Mars's history. Additionally, the hill/mounds you see within the landing site stood out to us. These are very beneficial for protecting the base from the rocket exhaust blast at the landing site, as well as protecting the base from the radiation of a nuclear reactor that would be used for power. Going back to the image that was the background of my title slide, you can see this concept in this drawing that my mentor Pascal created of what a human landing site and base on Mars may look like. I circled the landing pad at the base and the nuclear reactor in gray. Finding this candidate landing site means that humans potentially have a safe and convenient place to land and even set up a base in the Noctis landing region that would give them access to a relic glacier, and thus maybe water ice, as well as other sites of scientific interest in close proximity. As far as for where we are going to go from here, there are a few things we plan to do. First off, we plan to publish our finding. Additionally, we may try to acquire more high-resolution images of our landing site and surrounding exploration zone. These additional high-resolution images could also help us to determine if the candidate landing site we have currently chosen is, in fact, the best place to land. We could also look into how a base may be laid out at our specific landing site. We have learned that Noctis Landing is a promising area for future human missions to Mars, given that one could safely land there, set up a base, and be within short driving range, a few kilometers, from several sites of high priority science. To wrap up my presentation, I wanted to thank my mentor, Pascal, for his time. It was wonderful working with him on this project this summer. I also want to thank N3 for giving me this opportunity. Now, if we have time, I will take any questions.